A multi-wire branch circuit, often abbreviated as MWBC, is a type of electrical circuit that shares a common neutral conductor while utilizing two or more ungrounded conductors, also known as hot wires, to supply power to multiple loads. These ungrounded conductors originate from different phases of a polyphase electrical system, typically a single-phase 3-wire or a 3-phase system. The key characteristic of a multi-wire branch circuit is that the voltage between any two ungrounded conductors is higher than the voltage between any ungrounded conductor and the neutral conductor. This configuration allows for efficient use of conductors and can reduce voltage drop compared to running individual circuits for each load. In a typical single-phase 3-wire system, commonly found in residential settings, the voltage between the two ungrounded conductors is usually 240 volts, while the voltage between each ungrounded conductor and the neutral is 120 volts. This arrangement enables the simultaneous supply of both 120 volts and 240 volts loads using a single multi-wire branch circuit. The neutral conductor in a multi-wire branch circuit carries only the imbalance current, which is the difference between the currents flowing through the ungrounded conductors. This is one of the primary advantages of using a multi-wire branch circuit, as it reduces the overall current in the neutral conductor, minimizing voltage drop and conductor heating. However, it is crucial to ensure that the neutral conductor is properly sized to handle the maximum possible imbalance current. For example, if one ungrounded conductor carries 20 amps and the other carries 15 amps, the neutral conductor will carry only 5 amps. If the currents are equal, the neutral conductor carries no current. To maintain safety and prevent overloading the neutral conductor, the National Electrical Code, or NEC, has specific requirements for multi-wire branch circuits. One important requirement is that the overcurrent protection devices, such as circuit breakers or fuses, for the ungrounded conductors must simultaneously disconnect all ungrounded conductors of the multi-wire branch circuit. This can be achieved by using a 2-pole or 3-pole circuit breaker, depending on the number of ungrounded conductors in the circuit. The purpose of this requirement is to ensure that if one ungrounded conductor experiences an overcurrent condition, all ungrounded conductors are disconnected, preventing the neutral conductor from carrying excessive current due to an imbalance. Another critical safety measure is to avoid opening the neutral conductor while the circuit is energized. If the neutral conductor is opened while the ungrounded conductors are carrying current, the voltage on the circuit can become unbalanced, potentially damaging equipment connected to the circuit. This is because the loads connected to the circuit will be in series, and the voltage will divide according to the impedance of the loads. If the loads have significantly different impedances, one load may receive a much higher voltage than the other, leading to damage. To prevent accidental opening of the neutral conductor, the NEC requires that the neutral conductor be connected in such a way that it cannot be easily disconnected. This can be achieved by using a permanently installed terminal block or by ensuring that the neutral conductor is the last conductor to be disconnected when the circuit is de-energized. Now, addressing the question of whether circuits used to provide 240 volts power to residential ranges, hot water heaters, dryers, pool pumps, and other similar appliances are considered multi-wire branch circuits, the answer is yes. They often are, especially in residential settings where a single-phase 3-wire system is used. In these applications, the 240 volts appliance is connected between the two ungrounded conductors, while any associated 120 volts components, such as timers or controls, are connected between one ungrounded conductor and the neutral. This arrangement allows the appliance to draw both 240 volts for heating or motor operation and 120 volts for control functions. The 240 volt circuits for residential ranges and dryers typically consist of two ungrounded conductors and a neutral conductor. The range or dryer is connected to the two ungrounded conductors for the 240 volts heating element or motor, and the 120 volts components, such as the oven light or the dryer timer, are connected between one ungrounded conductor and the neutral. Similarly, hot water heaters that require 240 volts for heating and 120 volts for control circuits are also often wired using a multi-wire branch circuit. Pool pumps, depending on their voltage requirements, may also be connected to a multi-wire branch circuit. Some pool pumps operate at 240 volts and are connected between the two ungrounded conductors, while others operate at 120 volts and are connected between one ungrounded conductor and the neutral. It is important to note that not all 240 volt circuits are necessarily multi-wire branch circuits. For example, a dedicated 240 volt circuit that consists of two ungrounded conductors and a grounding conductor without a neutral conductor is not considered a multi-wire branch circuit. This type of circuit is commonly used for appliances that only require 240 volts and do not have any 120 volts component. The NEC defines a multi-wire branch circuit in Article 100 as a branch circuit that consists of two or more ungrounded conductors that have a voltage between them, and a grounded conductor that has equal voltage between it and each ungrounded conductor of the circuit and that is connected to the neutral or grounded conductor of the system. This definition highlights the key characteristics of a multi-wire branch circuit, which are the presence of two or more ungrounded conductors, a voltage between them, and a grounded conductor with equal voltage between it and each ungrounded conductor. Now let's talk about some NEC considerations for multi-wire branch circuits. The National Electrical Code, or NEC, provides specific guidelines and requirements for the installation and wiring of multi-wire branch circuits to ensure safety and prevent hazards. Firstly, NEC Section 210.4 covers multi-wire branch circuits. This section outlines the requirements for the identification of multi-wire branch circuits, the simultaneous disconnection of all ungrounded conductors, and the prevention of unbalanced neutral loads. Secondly, NEC Section 210.4b requires that multi-wire branch circuits originate from a panel board or distribution equipment. This means that the circuit must start from a dedicated overcurrent protection device, such as a circuit breaker, in the panel board. Thirdly, NEC Section 210.4d addresses the identification of multi-wire branch circuits. This section requires that the ungrounded conductors of a multi-wire branch circuit be clearly identified at the point of origin and at each termination point. This identification can be achieved by using different colored wires or by marking the wires with colored tape or labels. The purpose of this requirement is to prevent confusion and ensure that electricians can easily identify the conductors belonging to the same multi-wire branch circuit. Fourthly, NEC Section 210.4b1 and 2 requires that the overcurrent protection devices for the ungrounded conductors of a multi-wire branch circuit simultaneously disconnect all ungrounded conductors of the circuit at the point where the branch circuit originates. This can be achieved by using a 2-pole or 3-pole circuit breaker, depending on the number of ungrounded conductors in the circuit. The purpose of this requirement is to ensure that if one ungrounded conductor experiences an overcurrent condition, all ungrounded conductors are disconnected, preventing the neutral conductor from carrying excessive current due to an imbalance. Fifthly, NEC Section 300.13b requires that the continuity of the grounded conductor, or neutral, in a multi-wire branch circuit not depend on device connections such as receptacles or switches. This means that the neutral conductor must be continuous throughout the circuit, even if a device is removed or disconnected. This requirement is intended to prevent the neutral conductor from being accidentally opened, which can create a dangerous voltage imbalance on the circuit. Sixth, NEC Section 310.15 provides guidelines for the ampacity of conductors in multi-wire branch circuits. The ampacity of the neutral conductor must be sufficient to carry the maximum possible imbalance current. In some cases, the NEC permits the neutral conductor to be smaller than the ungrounded conductors, but only if certain conditions are met, such as the load being primarily nonlinear. Now let's discuss some common misconceptions about multi-wire branch circuits. One common misconception is that multi-wire branch circuits are inherently dangerous. While it is true that multi-wire branch circuits can be hazardous if not installed or maintained properly, they are generally safe when installed and wired in accordance with the NEC. The key to ensuring safety is to follow the code requirements and choose qualified electricians who are familiar with multi-wire branch circuits. Another misconception is that multi-wire branch circuits are only used in residential settings. While multi-wire branch circuits are commonly found in residential wiring, they are also used in commercial and industrial applications. For example, multi-wire branch circuits are often used to supply power to lighting fixtures, receptacles, and other equipment in office buildings, factories, and other commercial and industrial facilities. One more misconception is that multi-wire branch circuits are more complicated to install than standard branch circuits. While it is true that multi-wire branch circuits require careful attention to detail, they are not significantly more complicated to install than standard branch circuits. The most important thing is to follow the NEC requirements and to use proper wiring techniques. In summary, multi-wire branch circuits are a common and efficient way to supply power to multiple loads in residential, commercial, and industrial settings. They offer several advantages, including reduced conductor costs and improved voltage drop. However, it is crucial to install and maintain multi-wire branch circuits in accordance with the NEC to ensure safety and prevent hazards. Common applications include ranges, dryers, and hot water heaters.